So after we open the console, this is our interface. For this particular problem we'll go here, then we'll go to 2D. Then we are asked to select the kind of flow. There are different kind of options like AC, DC, acoustics, etc. We can go from fluid flow to, since ours is a single phase flow, to laminar flow, and then we'll add it. After adding the flow, we can select the study. Since our problem is a steady state problem, we will select stationary and then done. So we'll wait for the, so this is the interface. So now for this particular problem, how I have approached this is by creating 3 rectangles. So I select the first rectangle whose height will be 0.05 and the location will be 00 and build. So I have the first rectangle. Then for the second rectangle, the height will be 0.1 and the location will be 0.05 at x-axis. So this is created. For the third rectangle, we have a height of 0.05 and the location of y will be 0.15. Now this is build. Now we go to form union and build selected, so the union is formed. Now we'll go to the flow. So here, from here, we can give the fluid properties. In the question, since we are given the value of density, we'll enter that. So the value of density is 200, and also the mu is given. Mu is your 0.1. PAS we are given another unit, but it's similar. So now we can give the inlet and the outlet. So you select from here, and this is our inlet. And since we're given an inlet velocity, we'll put it here. Then we will select our outlet, which is this, this, and this, and we will keep this as usual. So we have made our geometry. We have given the fluid property. We have given the inlet and the outlet. Now we'll go for meshing. We'll select the physics control mesh only, and then we'll see our mesh. So our mesh is created. Now we will go for the study. So compute. We'll wait, and yes, so now in the question we are told to find out the pressure contour, the velocity contour, the skin friction profile, and the streamline. So for that we have here one data set is this, and we'll create one more data set which is cut line 2D. Now we will create one 2D plot. In the 2D plot we will go for the stream contour. First we'll go for the contour. So the contour will take the value from here and plot. So this is the velocity contour. Here we have the pressure contour, and now we will go for the streamline. So for streamline we'll again go here and select the 2D plot group, and okay, so here we'll select, we'll go for streamline, and streamline I have to streamline positioning, we'll put uniform density, and this is what we have. Let's make it a bit more dense. So yes, this is the streamline which we have. Now all we need is the skin friction. So for skin friction we have already created this. So again we'll go to results, and then we'll go for the 1D plot group, and in 1D plot group we'll plot the line graph. In the line graph here we'll take from this particular data set, and since we all know that the value of the skin friction coefficient is the shear wall stress, that's tau w by half rho u. So since we have the value of rho which is 200 and the value of u is 1, so half of 200 is 100, and up we have tau w which is your mu into du by dy. So mu is your 0.1, so 0.1 by 100 is your 0.001, and we have du by dy, so du by dy will be uy, and then we'll plot it. So we have the skin friction plot here. So thank you, assignment is done here. We have the pressure contour, we have the velocity contour, we have the streamline, and this is the skin friction. Thank you.